Alright, SAS class, let's look at this question that deals with significantly low or significantly high values. So this particular problem wants to know what are scores that are significantly low or significantly high. So it's got two parts, significantly low first, significantly high second. When I screen captured it, it only captured the low part, but I'll do both parts. So if a z-score, remember this is a z-score, it's defined to be a measurement, some x value unknown, minus the mean divided by the standard deviation. Okay, not necessarily unknown, it's just something that can change, it's random. The mean and standard deviation, however, are not. Okay, so the mean score here is 19.5. So if I just plug in, I got minus 19.5, that's the mean, divided by the standard deviation was 4.7. All right, now what test scores are significantly low? It just says it right here, anything less than or equal to -2. So if I start off by changing the z-score to -2, and now I just solve that thing for x, that will tell me what is considered significantly low or significantly, when I change it to +2, will tell me what's significantly high. So the first thing I need to do to solve for this is to clear out this fraction. I need to multiply the left and right by this 4.7. All right, if I do it to the right, I have to do it to the left to get it to cancel away. All right, and then if you multiply it out, -2 times 4.7 is -9.4. So I'll come up here, -9.4, and now the only thing left on the right hand side is the x minus the mean. All right, and then the last thing I need to do is to add the mean to both sides. I have to add that 19.5 to the left and to the right. And when I do, I'm left with x is equal to, this side will be 10.1. So 10.1 is a value that's considered significantly low. Now, the other side of the equation would say greater than or equal to 2 is the z-score. So again, I'm taking this formula, I'm changing now z to 2, +2. X minus the mean is still x minus 19.5. Right, and then I'm dividing by the standard deviation, which is still 4.7. All right, and now this time, when I go through and do the work, when I multiply by the +2 times 4.7, this time I get +9.4 is equal to x minus 19.5. And so when I add the 19.5 this time, I get 28.9 is the value. All right, so this is significantly low cutoff, and this is the significantly high cutoff. And you can see they are both, you can see they are both well away from our mean value, 19.5. Right? If we've done this correctly, I'm going to pull down my Desmos calculator I was doing to do the math. If we've done this correctly, the average of these two numbers, the 28.9, and the 10.1, right in the middle will be our mean of 19.5, and it's in there. All right, those are two standard deviations away from the mean above and below. So what do we mean by that? If I take two standard deviations, so 2 times that 4.7. If I multiply that by -2 and subtract it from the mean, I get that low cutoff. If I add it, I get that high cutoff. And that's the two numbers that we're looking for here. Okay, so anyway, that's another way you could have done it. Is literally, instead of like going through and doing an algebra, you could have just taken your mean, subtracted 2 standard deviations, and added 2 standard deviations. And that's another way to think through that problem.